Okay, now that we know what spectral tilt is, I want to walk you through the Korean stops exercise. So I've got this open here on my desktop. I'm also going to show you how to get to it through the home page. So there is a tab for homework exercises, and if you just click on that, it'll give you the homework exercises we've done so far. And then if you click on the Korean stops exercise, it gets you here. So there's a lab exercise, which is the PDF that I just showed you. This is what it looks like on the web. And then there's also a series of sound files. So there's 6 for 2 different speakers. There's also an example sound file. So I am going to walk you through how to take a set of acoustic measures for this example sound file. You can download that one just by itself now if you want to, or download all of them together. Either way, this is how I'm going to get started with this. I also will give you some context for this. This is going back to this 3-way contrast we get between Korean stops and also some other obstruents too, where we get leanus or unaspirated, fortis or fortis stops, tense stops, sorry, and then also aspirated stops in the language. So yeah, just so you know, on the web page itself, this specifies which stop is which. So the first and fourth are fortis, the second and fifth are unaspirated, and the third and sixth are aspirated. So keep that in mind. These are the glosses from Korean. This is what they mean in English. You don't really need to worry about that too much, except for the fact that the stops that you care about themselves are going to be at the beginning of this sort of target word here, and they're all going to be preceded by the same word, that, the determiner. Okay, so we're looking at data from 2 different speakers of Korean, producing 6 items in the first 2 rows of the table above up here. So we've got 12 different production items to analyze, and I'm just going to do the sample one, or basically the 13th, to play around with and give you an idea of how the exercise works. So this distinction only appears in syllable onset position. There's actually a limited number of contrasts you get in coda obstruents in Korean. And they're also being produced in this frame of that, whatever it is. Okay, so we're going to take our cues, for potential acoustic cues to the stop contrast from published work on the Korean stop distinctions. And in all, we're going to look at 5 different potential cues in each of the 12 production items. So you have to make basically 60 measurements for this. I'm going to add here that the very first time I constructed this exercise, 12 years ago now, I gave it to everybody. That was the first year I was in Canada. And I had 5 speakers producing all of these items rather than just 2. And I had my students calculate or make measurements for all these different cues for 30 different production items. So that's 150 measurements. And I had them all do it over the winter break, which I didn't realize at the time is the time when a lot of people would go to, Central America and lie around in the sun or something where it's not as cold as it is in Calgary. And my students were not super happy about that assignment. So complain about this all you want, but you've got it easier than people did in the past. Just like walking to school in the snowstorm and all that stuff your grandpa did. Anyways, here are the data you need to collect. So there's going to be 5 cues that you need to make measurements for. So what I'm going to recommend you do is make an Excel spreadsheet. I'm going to make this a little bit bigger, actually. So I'm going to walk you through just generally how you can transcribe these or take notes on what your measurements are. So our first measure is going to be for token 1_4, as I've got here. So that's corresponds to number 4 here. That's that horn, which is a fortis stop or a tense stop. Okay, but this is just our example. The first acoustic cue I want you to look at is whether or not there's voicing during the closure stop of the closure phase of the stop in the middle of the token. So I'll play this for you so you can kind of get oriented to how these things sound.
젖불.
Yep.
젖불.
So this is the word that.
젖.
And then there's a stop right here in the middle, right? It's bilabial. And if you just play it by itself, it sounds like that. So what we get out of this by placing the word in this sort of frame where the initial word ends in a vowel is that it goes from a vowel to the stop itself.
뿔.
So by itself, you could just say
뿔,
that means whatever, horn in Korean. But we actually get this whole sequence here where it's all stop, basically. So we know where the stop begins and ends. Yeah, so the idea is, at least according to the literature, that all these stops are supposed to be voiceless. So what I want you to do for this first cue is look at this part of the recording to see if there's any voicing in it. So I will point out here a common finding you'll get in these stimuli or recordings, which is that there's kind of a little bit of voicing here because the speaker is voicing for the vowel, and then she closes her lips to make the bilabial stop, and then there's a little bit of overlap between the voicing of the vowel before it ends and where the voiceless stop begins. So this is not a voiceless stop. You can kind of hear a little bit of a blip there, but this is basically, or sorry, this is not a voiced stop. I don't know exactly what I said. This stop is not voiced. It's voiceless. With just a little bit of bleed here from the previous vowel. If you see a voiced stop, it's going to look more like this. We're getting voicing all the way through the middle. And you get this kind of low frequency hum here in the spectrogram. So basically, what I'm going to say for that is, maybe I'll make this bold here. So these are my different cues that I'm looking at. And I'm going to say no for token 1_4. Okay, so that's my first cue. I can clean this up a little bit. And this also gives you examples of both voicing and not voicing. Like I said before, a lot of these have just a little bit of voicing at the beginning, but don't worry about that. All right, I'm back. Sorry for the break. I just patched up something in the homework, which has been bothering me for many years. Not since 2008, but close. So this should make it easier for you. But when we look at potential acoustic cue number 2, what we want to measure here is closure duration. So although closure duration is not generally mentioned as a cue to the fortis-lenis aspirated stop contrast in Korean, there appear to be durational differences in this data set between the 3 types of stops. Okay, so to examine the importance of this cue to the distinction, measure the duration of the stop closure in each production item from the offset of the first vowel to the release burst of the stop. So this is the part that many students in the past have gotten confused about, and I may have misled them. So I'm trying to be super clear about this now. In this example,
젖불,
we noted when we were looking at the previous cue that there can be sort of overlap of voicing between the vowel and the stop here, right? So what I want you to do is measure the amount of time from the offset of the first vowel where you see these formants end here, basically. And that may include some of this voicing overlap down at the bottom. You should include it if it's there. If there's voicing all the way through, you should include that too. And then go all the way to the release burst of the stop following that closure. So just this part. And then,
뿔,
right. So I'm going to get slightly different measurements here versus how I put this on the handout versus what we're looking at here in Prot. But let's just take this measure here. It's the same token. This shows you the duration of this segment of the waveform here, and it tells you what the duration is in seconds. So this is 0.159 blah, blah, blah seconds. Normally when we record measures of duration in phonetics, we measure them in milliseconds or thousands of seconds. So please make that conversion for this, and you can include one numeral after the decimal point. So what I would say you do there is 159.7 milliseconds. I'll put the units there just in case you're not clear on that. But see 159.7. That's all you got to do for that. And then you just have to find the right interval, basically, to highlight. Hopefully that makes sense, and I'll just reiterate once again, it's okay, and you should include any sort of overlap voicing here. Kind of the main thing you want to be able to see is that there are no vowel formants during this stop, and you stop at the point where you get to the release burst of the stop itself. So make note of that measure for closure duration, and you may see differences between the 3 types of stops in closure duration. They're not really predicted, but who knows? That's why we make the measurements, right? It's an empirical question, as they like to say in grad school and other academic places. Okay, so the third acoustic cue is voice onset time, or VOT, so I'll just abbreviate it that way, and we're going to measure this in milliseconds as well. So both the leanest and Fortis stops are generally described as unaspirated in contrast to the aspirated stops. So the extent to which a stop is aspirated can be measured in terms of VOT, which is the length of time between the release burst of a stop and the onset of voicing in a following voiced segment, usually a vowel. And you're going to be making VOT measurements for your course project as well. So in case you're unclear about that in any way, here's where you can learn more. So in order to do this, you need to first identify the stop release burst. And I've said here this generally appears as a transient vertical spike in the acoustic waveform. Transient just means something that goes by very, very quickly. And then a broad spike with energy all the way up and down the frequency scale in a spectrogram. And we can see that here. Usually for bilabial release bursts, they're going to be kind of weak in intensity, but we got a good one there. You're just looking for that spike. That's your landmark for measuring VOT. And then after that stop after a stop of any sort is released, you're going to have to get to voicing at some point in the vowel after it. For aspirated stops, the vocal folds remain open, enabling air to flow out from the lungs unimpeded, and that produces an H-like sound. So this is why we transcribe aspirated stops with the superscript H, so on and so forth. We covered that in 341. But you can see that nice and easily here in this example. This is the aspiration after the release burst, the spike at the beginning of the sequence. And you can see in the waveform too, with this kind of high frequency noise going on, and that's the release burst in the waveform. So to measure the duration of VOT in PROT, so then this is voicing afterwards, right? So you get this periodic repetition of glottal pulsing after the aspiration itself. I think that's a fairly clear distinction between the two. What you want to do is select the portion of the sound file from the stop release burst to the onset of voicing in the following vowel. And then the duration of this portion of the sound file can also be read off the bottom of the PROT window, and it's going to be in seconds, so multiply that by 1,000, and you get something like 89.3 milliseconds in this case. I'm going to show this to you in this example. This is a Fortis stop, so we're basically not getting any VOT for this. Here's my release burst, and my first voicing bar is here. So this is going to be extremely short, but try to measure that gap between the two. Actually, that's so small, I can't even read it, so we're going to even go smaller here, but something like this to this. So like 6 milliseconds. That's hardly any VOT at all, but that's kind of what you expect for the Fortis stops. It's easier to read this for the aspirated stops. This is what it looks like in that case. But basically going from the release burst, the difference in time between the release burst and the beginning of voicing in the vowel, that's VOT. Next, we have what I'm calling F0 onset. So one of the primary differences between the Fortis and leanest stops is that the vocal folds are stiffer for the Fortis variety. For this reason, F0 is normally higher immediately after the release of a Fortis stop, if you interpret this in terms of longitudinal tension, as opposed to a leanest stop. So Fortis versus tense versus unaspirated, in other words. So measure the initial value of F0 in the vowel that follows the stop in each production item. So for that, what I want you to do, we're already zoomed in nicely here, turn on the pitch tracker for this particular token. And it will give you this in, this one is a kind of smooth line form. If you want, what I want you to do is basically tell me where it begins right after the release of the stop. So you want to get the first F0 value or as close as you can get to it. So this says 222.1 hertz. If you want, you can tweak the pitch settings in a couple of different ways. So instead of having a curved, nice smooth line for your pitch tracker, you can make it speckles or dotted, which will tell you where the individual measurements are. They should be basically about the same, but if you want like a landmark for that first measure, you can just do present this representation. And it's the same thing, so 222.1 hertz. I'll just write that down with the units. I'm also going to mention a couple of things. I talked about those various errors that pitch tracking can produce when you turn it on and how you got to watch out for them. So make sure the pitch range you get or you have in place for your speakers is appropriate for the speaker's pitch range, right? So this is a female speaker. 100 to 450 is a pretty good range for her. You might lower it at the top end perhaps if you want. That might make it easier for you to see where the particular pitch measurements are. But don't do something wonky that like gives you pitch halving, like reducing this to 200, which is not a realistic pitch range for a female speaker. All of a sudden you're going to get like half of what you had before, like 111, right? So make sure that pitch range is set appropriately. We'll just leave it at 350 for now. I've also got a note here that in addition to watching out for things like pitch halving, watch out for any micro perturbations in the pitch track caused by the stop or aspiration immediately preceding the vowel. If you get some sort of like weird jump here, up or down, before it goes to like a smooth line, then ignore that initial jump when you're making the measurement of the first F0 value for your recording. And take the first one that looks like it's stable in terms of F0. Okay, lastly and most complicatedly, we're going to look at spectral tilt. So the vocal folds are supposed to be held closer together during the stop closure for the fortis as opposed to the leanest stops. It's also been claimed that the voice onset after fortis stops is relatively sharp, with less drop-off in intensity of the higher harmonics than is normally seen after the leanest stops. That's the spectral tilt I was just mentioning in the previous lecture. So basically we can infer that there's more medial compression of the vocal folds in the fortis stops than in the leanest stops. How do we measure spectral tilt to kind of confirm this? The first thing you need to do is take a spectral slice of basically, well, I've got 5 or 6 here, but basically the first first 5 voicing cycles of the vowel following the stop. So this is a tricky one. You want, because it's kind of repeating in weird ways at the stop. But what you want to do, I'll go sort of where it starts being obvious that we're getting the same repeating pattern. And I want to get 5 cycles. So this is kind of voicing for the vowel. Here's that little blip of sort of aspiration. This is the release burst itself in the waveform view. You are grabbing information from the waveform here, not the spectrogram. The waveform gives you better timing information than the spectrogram. And what you want to do, or make sure you do, is when you grab these 5 cycles of your waveform, that you start it at the 0 point. So where the waveform is crossing the 0 line is where you want to start and end. And the reason you're doing that is so that like these little weird ups and downs of the waveform don't give you sort of artifacts in your spectral tilt reading once you create a spectral slice. So I'm going to try to grab that as close to that 0 as I can. So this is sort of my first repetition of a complex wave cycle. You can see it kind of has a mini bump and then a big bump, mini bump and a big bump. I want to get 5 repetitions of those patterns. So there's 1, there's 2, there's 3, there's 4, and there is 5, right? So I've got 5 big bumps here, and I'm trying to get to that where it crosses at the 0, right there. 1, 2, 3, 4, 5. This is like I'm counting for my child. All right, but we're so much more sophisticated than that because we can calculate spectral tilt, and I'm sure my child won't be able to do that until she's at least 5. We'll see after that. Anyways, to get a spectral slice, you've got your little chunk of the waveform. Now go to View Spectral Slice, and it's going to give us this. So this looks like those power spectra we were playing around with before. That's just a little chunk of the waveform. This is a funny one. So I guess I'll add here as well. This exercise is not totally designed ideally, because what I would really ideally like to have if I'm looking at spectral tilt is a vowel that has a high F1 so that kind of the formants get out of the way of the lower harmonics in the signal. We're dealing with ooh here, so we don't have that luxury. So, okay, nothing's perfect. We'll just have to accept it. But to measure spectral tilt, what I want you to do is zoom in on the lowest harmonics of this power spectrum. And this is also why we measured F0, so we can kind of confirm what's going on with our measurements here. This is about 220 hertz in frequency for my first harmonic. That should be my fundamental frequency. It's pretty close, right? 222. And then this one should be twice that, so this should be about 440. If I can click on it. Something like that. Okay, there we go. So all I want you to do for the spectral tilt measurement is give me the intensity of H1 and H2, and then also the difference between them. So H1 is going to be at right about here, 51.4 decibels. And I'll leave it without the units here so I can have Excel do the math for me. And then H2 is 57.3. Yeah, so spectral tilt in this case is going to be a little weird because we are getting a negative measure. So it's H1 minus H2. Normally, when we look at the EGG waveforms, the intensity of the harmonics goes down consistently as we go up the frequency scale. Things are getting a little messed up here because we have a low first formant. So if we blah, about 440 hertz, we're already kind of in that first formant. So that's intensifying that first or second harmonic a little bit above the intensity of the first harmonic. So be that as it may, all I want you to do here is just take the difference between these two. So you can do that. You can type in a cell equals that tells the Excel that it's going to be seeing a formula in this particular cell, and then reference this guy. So this is F2, and then subtract from it G2, which is that cell, so blue minus red. Hit return, that's all you need to do, and you get negative 5.9. That's negative 5.9 decibels. That's your spectral tilt measure. But we expect lower spectral tilt measures for fortis stops, and this is a fortis stop, so because it's negative, it's really, low in terms of spectral tilt, so we don't have to get too worried about that. But that's basically how you do it. This one gives you a sort of more normal setup where H1 is higher than H2, but it's the same idea. You're subtracting the intensity of this guy from that guy to get your spectral tilt measure. Okay, and I think I walked you through in video form everything I wrote here on the homework itself. Those are your 5 measures, and yeah, just tell me what the H1 value is, tell me what the H2 value is, and tell me what the difference is when you give me your measures here, because what I want you to do is to send me your spreadsheet or record of whatever all these measures are in whatever form you put them in, as long as I can read and understand them. Then, after you've collected your data, I want you to ask or answer a few questions. So, first of all, state whatever patterns you see in the data you've collected, if anything in general jumps out at you, and then you can specifically talk about it in terms of the answers to these questions. So are each of the cues equally reliable in signaling the difference between the 3 types of stops? If not, then which cues are more reliable? I should fix that syntax, and then which are less. I think as I walked through this, I mentioned that some of these cues are not expected to be cues to the difference. So you can kind of anticipate that some of these may be more significant than others, but who knows? There might be some surprises in there. And so we've got this statement about our theory of voice quality holds that there should be greater spectral tilt after stops which have less medial compression, i.e. the aspirated and unaspirated stops should have greater spectral tilt than the fortis stops. Does this prediction hold? Did you find consistent differences in spectral tilt between the 3 kinds of stops? Are there differences between the speakers in terms of the cues they use to signal each contrast? And if so, what are they? And I'll mention, I guess, as well, I can't remember which is which, but one of these speakers comes from Seoul, the capital of Korea, and the other comes from, I think, Busan, which is a city on the south end of the Korean peninsula. So they're actually in different sort of dialect regions of Korean. So they may speak a little bit differently from each other with respect to these stops. Are there any differences in the cues between the 2 places of articulation? There's bilabials and alveolars in here. And lastly, are there any unexpected findings in your data? Please write this up in a concise and clearly written lab report, along with sending me your observations, i.e. your data that you've collected from this exercise, and then get those to me either by email or through the Dropbox by Monday, November 2nd. And I think that's everything you need to know, but if you have questions, you can always ask through email or stopping by office hours. So, right, have fun. Remember that you're doing 2/5 of the work that your predecessors did, and hopefully you'll learn just as much. Okay, see you next time.